By the end of the next decade, the first human feet will likely touch down on the dusty red soil of Mars. This is NASA's timeline, and it is by no means unrealistic. And while that first visit might be similar to a stop by in line with the moon landing, some scientists are claiming permanent human colonies could be set up on Mars as early as 2050. That means it could be you alive today and watching this video, who is the one who sets out to tame that new frontier. You'd need to get into a space program pretty sharply if you're not in one already, but it is possible that you'll one day look out of a little bay window and watch as our pale blue dot vanishes into distant space. But as you turn your gaze to your new home, what conditions can you expect to find on Mars? What challenges face any would-be Martian colonizer? What deadly weather will you encounter? What will the red planet throw at you? For unlike our home planet, Mars is a dead world, and anyone hoping to set foot there will need to overcome its daunting challenges with technology that is at the very cutting edge. I'm Alex McCone, and you're watching Astrom. Join me and a very special guest today in this supercut on the environment of Mars, as we explain both the hostile conditions and exactly what NASA is developing to help future Martians like you to tame those arid, rusted wastelands. And stick around till the end of the video for a very special announcement you don't want to miss. Music. It obviously to colonize Mars you first have to get there. The trip itself to Mars would take about 3 months with the most optimal launch conditions. This doesn't seem too excessive. It's like a long voyage on a cruise ship. But you have to consider that you would spend at least 3 months outside the safety of Earth's magnetic field. Out here, you are exposed to the solar wind and cosmic radiation. Prolonged exposure to this kind of radiation can cause astronauts to develop cancer and even symptoms of Alzheimer's before they reach Mars. Fortunately, there are some thoughts about how to protect against this. The astronauts could be shielded using materials in the ship's construction that are rich in hydrogen. In fact, the cabin could be surrounded by a water tank in the walls. Water being rich in hydrogen. Another option is to create a magnetic field around the spacecraft, but this requires generating a huge amount of energy from a reactor small enough to fit on the ship, something we don't have the technology to do safely just yet. Once therefore, an alien planet, Mars is not as foreign as you might think. Earth and Mars share a lot of similarities, one being the length of day. The solar day on Mars is only slightly longer than it is on Earth, 24 hours, 39 minutes, and 35 seconds. Its year is slightly longer than ours, 188 Earth years, or 1 year, 320 days, and 82 hours, but that's to be expected for a planet that's further from the Sun, and so has a larger orbit of all the planets in the solar system. The seasons of Mars are the most Earth-like due to the similar tilts of the two planets' rotational axes, 23.5 degrees on Earth and 25 degrees on Mars. So what does that imply? It means Mars has summers and winters just like Earth does. These temperatures in the different seasons can vary quite a lot, and different locations can widen the range. Even further, temperatures can be as low as minus 43 degrees Celsius at the polar winter caps to as high as 35 degrees in the equatorial summer. It has polar caps just like we do during each pole's winter. The pole lies in continuous darkness, just like on Earth. However, unlike on Earth, the temperature gets so cold that the atmosphere there freezes into slabs of CO2 ice, which collects on the surface of the permanent polar caps there. These caps themselves are not primarily made of CO2, but instead are made up mostly of water ice. The ice at the poles waxes and wanes. In this short video, you can actually see the differences of the size of the polar cap from the cap's winter to the cap's summer. One thing I love about Mars are these strange spiral patterns in the ice. Both of the poles show signs of these beautiful spirals, which scientists believe are a result of the Coriolis effect. The CO2 at the poles does not remain there forever. As the CO2 ice on the poles sublimates, it has a knock-on effect on another aspect of the planet. Its wind. Sublimation of dry ice can create enormous wind speeds, which causes one of the most unique and terrifying aspects of Martian weather. It's dust storms. If you peered across the rusted Martian surface through photos, you would be forgiven for thinking that Mars is a place of stillness. Flat, dusty landscapes seem to stretch out in all directions with nothing but scatterings of rock and the faint whistling of the wind to keep at bay the almost oppressive solitude. But stay a while on this red world, and you would soon see a towering wall of dust and sand brewing on the horizon. You might think to yourself that this dust storm is similar to those we see on Earth and have no idea that this storm is about to grow so large its thick dust will swallow up not just a region, not just a continent, But the entire planet, this all-enveloping superstorm, arises on Mars usually every 3 Martian years, or about 5.5 Earth years. Its choking dust will blot out light for weeks, even months, and represents a huge challenge to the continued functionality of any technology that we put up there if humans ever want to settle down on the red planet. It will be a hurdle we have to overcome, which is a problem, as there is much about the origins of these storms that we still don't know. Mars didn't used to have to deal with planet-sized dust storms. Although Mars is now a barren, arid planet, it once had a thick atmosphere that was warm enough to support the existence of running water. However, over the course of the billions of years of Mars's existence, Mars dried out, and its atmosphere bled away until atmospheric volume was at less than 1% of what we have here on Earth. Those dust storms didn't just start happening because Mars became dry, though. Although we don't understand everything about such storms' origins, we assume that a key component is Mars's temperature. With less atmosphere, in spite of Mars's high CO2 levels, Mars became far worse at retaining heat. When the surface starts to cool, there is no air to catch the escaping warmth. It is at the point where if you were to stand on the planet's equator during its warmest time of the day, your feet might feel 23 degrees Celsius, while at your head, it would be 0 degrees as mentioned earlier. This means between day and night, Mars has some intense temperature swings. Temperature differences can cause winds to form, which can bring different weather systems across the planet. However, Mars's arid weather is no longer driven by rain and water cycles, but cycles of dust. Dust plays a surprisingly crucial role on Mars, and without it, those planet-spanning storms would likely never form. The atmosphere might be too thin to capture and transport heat, but the Martian dust, now that's another story. It all begins with that Martian dust getting into the air. There are a few mechanisms that make this happen. One is dust devils, of which Mars experiences thousands every year, usually during the Martian spring and summer. Warm rays from the sun heat the ground, causing the air directly next to it to rise, and cool air from the atmosphere to be drawn down to fill the